welcome to my YouTube channel. So here today we are going to be looking at the enthalpy equations and other questions. So we are going to be solving all these questions and some true or false, some coming up with a thermometric equation, and also this interesting question which we solved a similar question in another video. Then we have some true or false and also that. So now we are going to begin with this one as our first question. So now how do you solve this one? So this just applies the same concept as the more concept and stoichiometry. So let's say if you have a 2 kwacha, let's say in 2 kwacha you can buy 4 pieces of bread if your economy is doing great. So if you can buy 4 pieces of bread, then they give you 1 kwacha. It simply means to say you will buy 2 pieces of bread, but let's say you don't know, you will say x, then multiply 2 by x, it will be 2x should be equal to 1 by 4 is 4, then you divide by 2, divide by 2, the result is that you have 2 bread. So in one, if you have 1 kwacha, it means you can buy 2 bread. So that is what this is simply about. So just you comparing with the equation that they have given you with the amounts that you can be able to use or rather produce. So we have this one. Consider the following reaction: 2 moles of magnesium plus the oxygen. Then we are told that should be able to produce magnesium oxide. Then we are told calculate the amount of heat transferred when 2.4 grams of magnesium reacts at a constant pressure. So we are going to say that the value for this one will be, look at what they have given you. They have given you magnesium. So you are going to take this magnesium, you are going to treat the molar mass to be the mass itself. And the difference is that for mass, you are going to consider the number of moles, this number in front. For what's this? If you are looking at for the molar mass, you don't consider the number in front. But since we are going to consider it as the mass, it means we look at the number in front. So if you are looking at magnesium, you are going to say 2 of magnesium. So the mass of magnesium from the periodic table is 24 grams. You are going to multiply by these 2, which will give you 48 grams. So 48 grams, according to this equation, will produce this amount of heat. So you are going to say 48 grams will be able to produce negative 1,204 kilojoules. Then you ask yourself, how about 2.4 grams? So you are going to say 2.4 grams will produce, you don't know. Then cross multiply 48 times x, this will be 48x should be equal to 2.4 times the negative 1004 kilojoules, like that. So divide this by 48, divide this by 48, then the value will be equal to x should be equal to, we are going to multiply, which will give you, so we have our 2.4 times 1004, which will give us 2,889.6. We divide by 48. We are going to find that our x value will be equal to, so divided by 48, this gives us a value of 60.2 kilojoules. So that's how basically you solve that one. Then the next one is, how many grams of magnesium oxide are produced during an enthalpy change of this? How many grams? So they want a mass. You are going to use the same thing, but you are focusing on this. So 2 moles of magnesium oxide will produce this amount of the energy or enthalpy change. So you are going to be comparing with this. So you are going to say 2 of magnesium oxide, you are going to have whatever you will have, you will multiply by 2. So oxygen is 16, magnesium is 24. So when you add these 2, you are going to get 16 plus the 24, which gives us 40. So 40 times the 2, which will give us 80. So this 2. So we have 80 grams. So this means that if you have 80 grams, you are going to be able to produce this amount of heat. So we have negative 1,004 kilojoules. Then what if you have this amount, 2.4 grams, not this one, we are solving this one, are produced how many grams of magnesium oxides are produced during an enthalpy change of 96 kilojoule. So we are looking at for magnesium oxide. So we are going to have, what if you have produced, so I just brought this equation to bring back the balanced chemical equation, but it's not important since we have solved number 1. Now we are on number 2. So how about the 96 kilojoules? So what mass can be able to produce this? So you say X, you cross multiply, then this times this, it will be negative 1004 kilojoules should be equal to 80 times the 96. Now if you're finding mass can never be negative, so you ignore this. So this will be X, this by this it will be X. Then divide 1004 kilojoules on both sides, 1004 kilojoules. Remember, this is the kilojoule, this is the gram. So that's how come the gram remains. So our X should be equal to, we have 80 times 96. This gives us 7,680 over 1,204. Then we have our X should be equal to this divided by 1,204. So this gives us a value that is equivalent to 6.38 grams. So this will be our mass for that one. Let's move on to our next problem. So we have how many kilojoules of heat are absorbed when 7.5 grams of magnesium oxide are decomposed into magnesium and oxygen at a constant pressure. So this is still dealing with the same equation. So allow me to just lift this. So lifting this, we are going to have this balanced chemical equation. It says how many kilojoules of heat are absorbed when 7.5 grams of magnesium oxide are decomposed into magnesium and oxygen at constant pressure. So we are talking about decomposing. So that means to say we are moving from this to this. So the arrow is reversed. So that means to say our new equation is 2 MgO, a sulfur, to produce. So decomposed, we have Mg plus our O2. So these are the products. So now if we reverse the equation, remember according to S's law, it simply means to say the sign of the energy changes. So we are going to have the positive 1004 kilojoules. Then we are told that, so we are solving this. Don't pay attention to this question. It's just that it's the one that is having the equation. So we are told that how many kilojoules of heat are absorbed when 7.5 grams of magnesium oxide are decomposed into magnesium and oxygen at constant pressure. So we are going to use the same, since they have mentioned magnesium oxide, we are going to say 2 magnesium oxide, we found it to be equal to 80 grams. So be careful on which one you use. You use the one that they have told you, 7.5 grams of magnesium are decomposed into this. So you are going to have your 80 grams will be able to produce a positive 1,204 kilojoules. How about if you have the 7.5 kilojoules? So the work is, or rather the enthalpy is, you don't know, so you cross multiply. So 80 by X, it will be 80 grams. X should be equal to this 7.5 grams. 7.5 grams should be equal to, so we have 7.5 grams times 1004 kilojoules. So this gives us, divided by 80, we are going to have our X should be equal to, we have our 7.5 times 1004, then divided by our 80 grams. This gives us a value that is equivalent to 113, or rather 112.875 kilojoules, like that. Positive for that matter. So you get your 9 marks like that if questions come like that, if these types of questions come. So we have an LP gas tank in a home barbecue, contains 13.2 kg of propane, which is our C3H8. Calculate the heat in kilojoules associated with a complete combustion of all of the propane in the tank. So what are we going to do? So to answer this one, we are going to do the same. So we are looking at propane is the one that they have given us. So we are going to calculate the mass of propane, which will be, so we have our 8 times the molar mass of hydrogen is 1.01. So when we multiply this, we are going to have 8.08 grams, like that. We add we have 3 carbons. We have our 3 carbons times carbon has got the molar mass of 12.01. You are going to treat this as your masses, which will give you our 3 times our 12.01. This gives us a value that will be equal to 36.03. So when we add these two, we are going to get 8.08 plus our 36.03. This gives us a value of 44.11 grams, like that. So therefore, you are going, if you have 44.11 grams, it is going to give you this amount of heat energy. So you are going to say 44.11 grams will produce negative 2220. Is it like this? 2244. So we have 2044. So we have 2044 kilojoules. Is it kilo? Yeah, kilojoules. Then what if you have the 13.2 kilogram? So if you have the 13.2 kilogram, now remember it has to be in grams. So the kilo, be careful. Kilo, just remember that kilo is 10 to the power 3. Then you say grams. That means you have converted. So this should be equal to x. If you want, you can convert to grams using the usual way, but kilo is just 10 to the power 3. So if you just put it there, it means you have converted. So we are going to cross multiply. So it will be 44.11 times x, which will be 44.11x, should be equal to negative 2044 kg. Then times, we have our 13.2 times our 10 to the power of 3, like that. Then we have the grams. So this divided by 44.11, we divide this by 44.11 grams. So this is going to give us a value that will be equivalent to, we have our x is equal to, so on top, negative 2044 times our 13.2 times 10 to the power of 3. This gives us a value of negative 269.80800 divided by our 44.11. So this is going to give us a value divided by 44.11. This gives us a value of 611670.8229 kilojoules, like that. So this is how you find the change in enthalpy, like that. It's as easy as that. So that is how you find for that one. Let's move on to our next question. Let's look at this one. State whether each of the following statements is true or false. We have, if the enthalpy of combustion of propane gas as this is negative 2,220 kilojoules per mole, then the enthalpy change of combustion of 11 grams is 555. So we need to confirm this. So the enthalpy of combustion, meaning you are burning it in oxygen. So we say C3H8 plus. So hydrocarbons, when you burn them, we are going to produce carbon dioxide and water only. So we have plus our H2O, like that. So make sure that the equation is balanced. Now how you balance this equation is that do not affect the hydrocarbon. So just make your changes there. So we are going to have, since there are 8 hydrogens, so we are going to put 4, so that 4 times 2 is 8. So we have 4 oxygens. Then carbons, we need 3, so we put a 3 there. So we have 6 oxygens plus 4, that's 10, like that. So that's 10. So to get to where we want, we are going to just put a 5 here, because 6 plus 4 will give us 10, like that. So this equation is the one that will be able to give us the change in enthalpy, which is equal to, the change in enthalpy is equal to negative 2220 kilojoules per mole, like that. So therefore, how about if you have 11? So same approach. You're going to get this, find the molar mass. So the molar mass, treat it as your physical mass. We found this, we have already dealt with such. It was giving us 44.11 grams. Then get your 44.11 grams, equate it to the value, which is our negative 2220, like that, kilojoules per mole, like that. Then what we're going to say is that, what if you have 11 grams? So this will be equal to, you don't know, which is your x. So you're going to do your 44.11 grams. 44.11 grams, x should be equal to 11 grams times the negative 2220 kilojoules per the mole. So you're going to have over the 44.11 grams over the 44.11 grams. So this gives us a value that is equivalent to, so we have our 11 by our negative 2220. This gives us a value of our negative 24,420. Then we have kilojoules per mole. Then we are going to divide over the 44.11, like that. So this gram and this gram have gone. So dividing this, we are going to have our negative 24,420 divided by 44.11. This gives us a value of x is equal to negative 553.62 kilojoules per mole. So if you see, this is positive, that is negative. Even if it was giving us a 555 kilojoules per mole, it is still not true, because this is having a positive, the other one is having a negative. So we can say that this is the enthalpy propane, the enthalpy change of combustion. Yeah, so this one is force. Looking at this one, if the reaction is carried out at a constant pressure, the heat change is equal to the enthalpy change. So this is true. So as long as you have, if the reaction is carried out at a constant pressure, the heat change will be the same as the enthalpy change. Then if you look at this, the internal energy of the system is constant if no work is done on or by the system and no heat is exchanged. So remember, the change in the internal energy, which can be represented as, is equal to the heat plus the work. So if there is no heat and there is no work, that means 0, 0. Then the change in the energy will be 0. That means to say it will be constant. So we have the internal energy of the system is constant if no work is done on or by the system and no heat is exchanged. Then that simply means to say the internal energy is constant, which is our true. Last but not the least, we have the standard enthalpy of formation for carbon dioxide is given by this equation. Now to answer this equation, we need to define what the standard enthalpy of formation is. So what is the standard enthalpy of formation? So the standard enthalpy of formation is defined. So the Standard enthalpy of formation is simply defined the enthalpy change when one mole of a compound is formed from standard elements in their standard forms. So this is the simple definition, the enthalpy change. So this is the standard enthalpy of formation, which is just the enthalpy change when one mole of a compound is formed from its constituent elements in their standard states under standard conditions, which is usually 1 bar of pressure or 298 kelvins. So 298 kelvins is about 25 degrees Celsius. So now what do we mean? Like for example, if you want to produce oxygen, or if you want to produce carbon dioxide, you are going to add carbon, which is a graphite, plus the oxygen. So anything other than this, that means it's not so to form carbon dioxide. So this is what we call standard enthalpy of formation. It is when one mole of a substance is formed from its constituent elements. So the elements are carbon and oxygen. If you are looking at, let's say, carbonate plus another thing, this is just an example to produce carbon dioxide. This is not the standard enthalpy of formation, because this, in its standard form, carbon will exist not even as a gas, but it will exist as a solid, which is graphite, naturally. So now if you look at this question, so if you look at this equation, we have carbon monoxide. Carbon monoxide is not the standard state of carbon. It's carbon plus the oxygen, like that. Then it will be able to produce one more. It has to be one more. So that's why they are balancing by half there. So everything is correct except the carbon monoxide. So this statement is false, like that. So with that definition aligned, let's now answer these other questions. So we have the standard enthalpy of formation of iron 3 oxide at 298 is this. So write the thermochemical equations corresponding to the following. So we just need to produce one mole of iron. So we are going to have, so likewise, if you have, let's say, carbon plus oxygen, then this is producing something like carbon plus oxygen to produce carbon dioxide. This is the standard enthalpy of formation. But if the equation is reversed like this, to produce carbon plus oxygen, this is not the standard enthalpy of formation equation. So you have to produce the compound. So in this case, we have the enthalpy of formation of iron 3 oxide. It means what are the components that are needed? It's iron and oxygen. So we are going to say iron plus the oxygen to produce iron trioxide, which is like this. So iron 3 oxide is like this. Yes. So make sure that the equation it only has one on the compound. So we are going to have so let me move this a bit here. So we are going to have, if you look at this, we have 2 ions, so we can put a 2 here. We have 3 oxygens here. That means to say we can put a number on oxygen. Since we have 3 oxygens, we can put a 3 over the 2, so that 3 over 2 times 2, we are going to cancel this. This is going to give us 3. So 3 oxygens and 3 oxygens this side. Make sure that the only number on the compound is 1. So this will now be able to correspond to this. So we have our negative 842. So we have the change in enthalpy should be equal to negative 824.2 kilojoules per mole, like that. Then likewise, even this one, we have the standard enthalpy change at 298 Kelvin. So as you can see, this is the standard for the reaction between gaseous phosphorus trichloride meaning to say there are 3 chlorides, and chlorine gas to give gaseous phosphorus pentachloride, like that. So what are we going to write? So we are going to say our P, so the second one is our P trichloride, so it will be 3 chlorines. So if it is attached there, it means 3 chlorines plus the chlorine gas. Chlorine is diatomic, so we are going to have 2 of them to form that. Then this will give us phosphorus pentachloride, which will be PCl5, like that. So then the change in enthalpy, check if it is balanced, check if it is gaseous, so we have gaseous here, check if it is balanced. So we are going to say the change in enthalpy for this one will be equal to, let's reduce, so the change in enthalpy for this one will be equal to our value, which is our negative 84.3 kilojoules, like that, then per mole. So then the other one, we have the standard enthalpy of combustion of liquid ethanol or the standard enthalpy of combustion of liquid ethanol is this. So to write this one, we are going to have, so now when this is a gas, this one is a solid gas, then we have the solid, like that. Finally, the third one is the standard enthalpy of combustion of liquid ethanol. So liquid ethanol has got the chemical formula, which is equivalent to, we have our C2H5OH. So this one, combustion, it means it's burnt in oxygen, so we have plus O2 to give us the 2 products of burning alcohols is CO2 plus our H2, or like that. So this is what we have. Then let's look at the balancing, is the equation balance. So we need 2 oxygen or 2 carbons, so we're going to put our 2 here. Then we need 5 hydrogens. What are we going to put here? So we need 6 hydrogens to be specific, so we are going to put 3, so that 3 times 2 will give us 6. Then we have the number of oxygens, it's 3. This side it is 4 plus 3, which is 7. So we need 7 oxygens, so we are going to say a 3, so that 3 times 2 is 6 plus this one. So this is what we have. So the liquids, we have the gas, carbon dioxide gas, we have the water as a liquid. So the change in enthalpy for this reaction is equivalent to, our change in enthalpy according to this is the change in enthalpy will be equal to, we have our negative 1368, then we have the kilojoules per mole, like that. So that is how we answer those questions. Let's look at our last question. Identify each process as endothermic or exothermic and indicates the sign. So sweat evaporating from the skin. So this one, we have then water freezing in a freezer, wood burning in a fire. Remember, sweating absorbs absorbs heat. Remember, endothermic has to do with absorption of heat. Exothermic has to do with the release of heat. So if you are looking at the evaporation, let's say this is the body, then if you have let's say sweat, when sweat is forming, it absorbs heat from your body, which is the system, and from the surrounding. That's how come for it to evaporate, to go up, it needs energy. So due to the fact that it absorbs heat in order for it to evaporate, it will be what we call endothermic. So endothermic, because it's absorbing heat. then the sign of that, it will be a positive change in enthalpy. So you have answered that. Water freezing in a freezer. So if water is in the freezer, the only reason why, let's say if this is the freezer, then we have water here. The only reason why the water will be able to freeze is simply because when it was a liquid, it was releasing heat. So if it is releasing heat, it is becoming more and more cold. And if it's becoming more and more cold, it means to say it will be able to freeze. Due to the fact that it has frozen, that's the reason why it is an exothermic reaction, because it is releasing heat. That is how the mechanics of the fridge works. That's how come you will find that a long time ago, maybe you might, when you wash your socks very late, you will put them at the back of the fridge, because the fridge is releasing heat. That heat it is releasing is from the inside, so that is exothermic. So it is exothermic. So exothermic, their characteristic is that the change in enthalpy is negative. So the negative change in enthalpy. Then the wood burning, if it's burning, it is releasing heat. So the change in enthalpy, this is exothermic. The change in enthalpy is negative change in enthalpy. So that is it for that. Let's look at our final question, which is this one. So similar to the other questions which were involving work and the internal energy, we have glucose is the primary sugar in your bloodstream, supplying energy to your body. Dietitians are therefore very interested in the energy resource that it represents and need to investigate the enthalpy change that accompany its reaction. A constant volume calorimeter showed that the heat generated by the combustion of 1 mole of glucose in the reaction. So now we have this value, we have the change in the energy is given as this, then we are told what is the change in the enthalpy for the same reaction. So the change in the enthalpy that we gave last time as the formula provided with the change in the energy is equal to the change in the internal energy plus the change in the number of moles of the gas times the R times the T. So R, you use this R. So we are going to have our, let's find our change in the NGRT. So the change in the number of moles of the gas, you look at the product. So this equation, you must balance it. So it will be our C6H12O6 plus 6O2 should be able to become, okay, let's move this a bit down, should be able to become our 6CO2 plus our H2O, like that. So this 6, so that we can have 12 hydrogens, then we have our 18 oxygens this side and this side. So that means to say the equation is balanced. So Ng, the change in Ng here, so we are just looking at the change in Ng, the number of moles, it will be, the change in Ng will be equal to the number of moles of the gas of the products minus the number of moles of the reactants. So this is going to be our products is you add, so this is the gas, so we have 6 plus 6, which will be 12. So we are going to say 12 minus the number of moles of the reactant. So the reactant is, we have the gas, you look at the gas, so we have 6. So we are going to say minus 6, which will give us 6 moles of the gas. So that is how we do that. Then we are going to now multiply. So the change in NGRT will be equal to the 6 moles times the R, which is our 8.314 kilojoules per So this is what we have. The units, you can skip them. Then we have times the temperature. It is a, what is our temperature? We have our temperature is positive 298, so we are going to say 298 like that. So we have 298. So we are going to have the change in NGRT should be equal to, we have our 6 times 8.314, then this times our 298. This gives us our 14,865.432 like that. Then this is joules. So make sure that the units are like, this is kilojoules, so make this also to be kilojoules. So kilojoules means you're going to move 3 times this side so that you have 14.865432. So by moving 3 times, you're going to say 10 to the power 3. So if you're moving this side, it will be positive joules like that. Now you know that 10 to the power 3 is a kilo, so we have 14 points, we can round it off, 14.9 kilo, where there is 10 to the power 3 joules like that. So this is the change in NGRT. So therefore the change in the enthalpy, will be equal to the change in the energy plus the change in the NGRT. So we are towards the change in the energy is negative 2559. So we have 2559 kilojoules. Then we have plus our 14.9 kilojoules like that. So this gives us a value of negative 2559 plus our 14. This gives 14.9. 2559 plus, so negative 2559 plus our, these are a lot, negative 2559 plus our 14.9. this gives us a value that is equivalent to negative 2544.1 kilojoules. So this is the change in the enthalpy. So that's that. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.